Okay, I wanted to give you a little bit of help with your labs. Uh, since I can't be there in person, we're going to try to do this by visualizations here on some current weather. This is an actual surface chart from today at 19Z, which would be 3 p.m. Eastern Standard Time, Eastern Daylight Time, excuse me. Uh, so if this is today, then what are we looking at here? Everything plotted on here right now is pressures, and these are in isobars, which is the typical unit that most meteorologists use. So you're going to see a lot of isobar pressures. Isobars are just lines of equal pressure, and the pressure is in millibars. So here, for example, is a line that is 1,012 millibars. So if I go up that line, everything to the left of that line should be lower, and everything to the right near that line should be higher. You'll see here's 1,014, here's 1,009, 1,010, 1,015. So kind of holds. This is 1,016 millibar line. Again, one side of it has higher, one side of it has lower. However, you'll notice there is one reading here that, could be misplaced, but they're never a guarantee that all the readings are accurate. So the information we plot, how we plot it and all, is always an approximation because we just don't have data in here. It would be very nice if we had a couple other observations right in here to say, oh, this is where this should go. But we don't right now. Out here, this is high pressure because this is the highest pressure in this area. If I ask you to find the low pressure, well, there's an L, which kind of indicates low pressure, but the pressure is 1,007 millibars. Everything around it is slightly higher. There's another low pressure up here over Canada. Here's 1,000 millibars, so that is less than 1,000 millibars. So that's how you look at pressures on a weather map. Here's the highest pressure over the northwestern parts of the United States and northwestern Canada here. It's 1,028 millibars. So, and you may see questions that ask you to draw lines like this and find pressures along the lines, or find the highest pressure on the map or the lowest pressure on the map. So this is your introduction to that. Just analyzing, all you're doing when you analyze a line is make sure one side of it's always higher, one side of it's lower. In this case, the one side that's lower is to the left of the line, and the higher side's to the right. In this case, if I'm going along this line, the left side is higher, the right side's lower. If I'm going this way, just be the opposite. So, hope you get a little bit of understanding with that. I wanted to go up over to the surface. All right, if you're going to plot a weather map and look at a surface weather map, every one of these stations here is a surface reporting observation station, be it through ASOS or other means. Each one of these has reported at this time, which is 2 o'clock Eastern Daylight Time on this Saturday. So we're going to pick a site. And it's a little hard to read right here, but let's take this one on the Great Lakes. I'm not exactly sure where this is, Milwaukee. All would be in here somewhere, but I am not sure all my stations here. But let's start at the upper left-hand corner. The upper left-hand corner of a surface weather map will always have your temperature. In this case, 79 degrees. So the temperature here is 79, and the dew point here is 60. So dew point is a measure of moisture. The closer they are together, the more moist the atmosphere is. So you can see here we have that. Upper right is the pressure. You see it's in 0.84. Well, the last one, there's a decimal point before, so it's 0.8.4. But we know that pressures, we just looked at a pressure map. The isobars were all 1,010 or 1,012 millibars, 1,016 millibars. So the pressure is always a 4-digit plus a decimal. So it's 5 digits long. So if the pressure is 5 digits long, I need something in the front here. And if this is below 500, almost always there's going to be a 10 in front of it. So this is 1008.4. So if I was drawing 1,008 millibar isobar, I'd be pretty close to right here, but I'm not. So that is the pressure. If I say, oh, let's look at this pressure over here in another part of Milwaukee, Wisconsin here, it's 1,010.6 millibars. Now, if the pressure is above 500, say it's 599, the likelihood is that it's going to be 959.9 millibars, or a low pressure. And that would be a pretty strong low pressure, I'll be honest. Could be high, depending on what you're looking at. In other words, you look at the pressures around it in an area. So we know everything here is high pressure. We know if we go up this way, up into Canada here, we're getting lower and lower pressures. And here we have one, a 978. So this is 997.8 millibars, 997.6 millibars. So the other thing now we've talked about the pressure, a temperature, a dew point. What about cloud cover? Well, I look at my circle. The circle is located right where the observation is taken. That circle is like you were looking at the sky right above that location. See, there's a little bit of coverage here. Whole thing's blacked in here, just a tiny bit here. This would be saying that there's some sunshine, a decent amount of sunshine actually coming through. None here, completely cloudy. So that's how you look at that. Some of these are going to be totally clear, nothing in them. And that's a sunny day, bright sunshine, no hardly any clouds in the sky. Others have much more clouds. So now you know how to look at the sky above it as well. So now you have learned that if I told you what the weather was in one of these locations, you would be telling me the temperature, the dew point, the pressure, the cloud cover. What about wind? Wind is what the air is in motion. So we want to know what the wind is. You'll see here there's a little arrow kind of thing with a 1/2 of a barb on it. Here's a full barb, and you can see the difference. Well, notice this wind direction. If you were to think of degrees around the circle, the top of the circle would be 360 degrees. The bottom is 180. 360 is usually to the north. 180 is to the south. 270 is to the west. 90 is to the east. So this line is intersecting at about 190. So that is a southwest wind. The wind is coming from this location to this location. The opposite is here. The wind is coming from the north, moving into this. So we have a north wind here, south wind here. All right, so now you can tell the winds. You can see how strong they are. This indicates 10 knots. This indicates 5 knots. Not a lot of wind anywhere right now today. Here's actually 20 knots though. You can see a little bit stronger down here. And here is just another 5 knot. If there's just a circle around the other circle, it means the wind's calm. Finally, we want to know if it's raining, snowing. What is it doing outside? Well, there's a symbol between the dew point and the temperature. If there's nothing there, it's not precipitation. If there's 2 star dots like this, it's light rain. If they were stars, that would be light snow. If there's a triangle with it, it means it's a shower. It's not happening constantly. It's intermittent. So these are the different symbols that you're going to see on a weather map. Again, they're going to be in your lab. There's a whole explanation in there as well, but I'm just showing it to you ahead of time. So I wanted to show you a little bit more here. We have different ways of looking. We're going to call it remote sensing. If I am doing remote sensing today, one of the methods I would use would be satellite. Satellite is a system where I'm just looking down on the clouds from above. There are lots of potential ways of looking at these clouds. I can look at a band of radiation coming out and see water vapor at different heights. I can look at another band and actually see dust. And the one I'm just going to show you right now, we'll loop it here quickly, is going to be just a visible satellite. In other words, if you were up in the sky and looked down, this is what you would see. However, another thing I can use for remote sensing is lightning data. These are all strikes of lightning. The more intense ones go towards purple and eventually even go towards white. That is a lot of strikes hitting the ground at once. Less down here as well. And you can see, actually pick out, there's a new thunderstorm popping right here. And you can see the lightning starting to form on it. Or over here, there was no lightning. Ah, here we have lightning all of a sudden. So this is a great way to determine where thunderstorms are. And this can be utilized as well with the radar, again, which would show you these areas as well. And you're going to be seeing these in your labs. Each lab is going to have something a little bit different. And finally, I wanted to show you the upper air in a way. This is a profile. I should mention the SQTs earlier. This is a Stuvie diagram. All it is, temperatures along the bottom, pressures, as we've already learned in millibars, is on the left. So we start out with temperature at 1,000 millibars, and it looks like it's about 21 degrees Celsius. Dew point right here, probably about 19 degrees Celsius. If I go up, say I'm looking at 850 millibars, which is roughly around 5,000 feet up, I have a temperature. Looks like about 17. Dew point, maybe right in here somewhere. Looks like about 5 degrees Celsius. And here you can have the winds. We know now that the winds are blowing from the northwest here. They're moving to the west here. Stronger up here. The collared in pennant means 50 knots of wind. So this is where the strongest winds are located, right in here. So finally, let's just see if we can see one last thing. Is an upper air chart. This is 500 millibars, about halfway through the atmosphere. Instead of isobars, we use contours. Contours are height. So in other words, everything on this map that is plotted is at 500 millibars. That is our reference. It's not at 10,000 feet. It's not at 5,000 feet. Not at sea level. It's at 500 millibars. So we're using pressure to draw a map. So all we've done here is say at this pressure level, the contour is 5,820 meters. Here it's 5,880 meters. Here's the low. A low pressure would be because of lower contours means lower pressure. You can also see the wind. These are locations where observational data was available. Maybe from satellite, maybe from radiosonde, different methods. And you can see a temperature at that location, the wind, dew point, which gives you an estimate of how much moisture is up there, and 580 or 579 usually would add a 0 to the end of these to give you your contours. All right, that should help you with these first few weeks of labs. Again, if you don't know it, don't feel comfortable, please do not hesitate to ask, because the labs are 30% of your grade.